The question says that figure 9.30 shows an equiconvex lens of refractive index 1.50 in contact with liquid layer on top of the plane mirror. A small needle with its tip on the principal axis is moved along the axis until its inverted image is found at the position of the needle. The distance of the needle from the lens is measured to be 45 cm. The liquid is removed and the experiment is repeated. The new distance is measured to be around 30 cm. What is the refractive index of the liquid? So in this arrangement, there is a lens and there is a liquid layer, and this is a plane mirror. Now there are two cases. In one case, there is a liquid layer of some refractive index that is unknown, and we have to find out that refractive index. And in another case, the liquid layer is not present. So in the case when the liquid layer is present, the image of a pin that is on the position PQ is formed on the same position, and in the case when the liquid is not present, the same repeats as well. The only change is the distance between the object and the lens and mirror system. So in the case when the liquid is present, the distance is 45 centimeter, and the case when the liquid is not present, it is 30 centimeter. So this is a question of the combination of lenses and also the reflection of a plane mirror. So we know that a position of image in the case of plane mirror is same in magnitude as that of the object, that is u equals to v. And if the object is real, virtual image is formed, and if the object is virtual, real image is formed in the plane mirror. Now here, in both the case, with or without the fluid, the object is virtual for the plane mirror, so the real image is formed, which is being superimposed on the object. Now, if we remove this mirror, the question is very much simplified to the sign convention. Like if we remove this mirror, the image that was forming on the left hand side of this lens system will form on the right hand side of the lens system. We can simplify this question by changing the sign convention of V to a positive, because if there was no any plane mirror, then the image would have formed on the right hand side. And also plane mirror does nothing with the magnification. And also the position of image remains same, that is the magnitude remains same from the object. The image forms at the same distance. So let us assume the case when there is no any liquid. So when there is no any liquid, then we can calculate the focal length of this lens as 1 by focal length of the lens would be equal to n minus 1 by r1 minus 1 by r2. This is the lens maker's formula, where n is the refractive index of this glass that is used to make this lens, and r1 is the radius of curvature of this side, and r2 is of this side. R1 would be positive because its center of curvature would lie on the right hand side of this lens, and R2 would be negative, and they both are of same radius of curvature, so we can write it as R, and thus we will get 1 by F lens is equals to 1 by R. Now in this case, without the liquid, the image and the object were at 30 centimeter in front of this lens. So we can assume that V equals to 30 centimeter when there is no any plane mirror, and when there is plane mirror, then V would be equal to minus 30 centimeter. So for simplification, I have just removed this plane mirror, so V would be equal to 30 centimeter and U would be equal to minus 30 centimeter. So using lens equation now, we will get the value of R or F. Since F of this lens is equals to 1 by R, so we can easily write that 1 by 30 plus 1 by 30 equals to 1 by R. This will give us R equals to 15 centimeter. That is the radius of curvature of this lens is equals to 15 centimeter. Now we will proceed with this case when there is a liquid. Now when there is liquid, then the refractive index of this liquid be mu2. Then now it is a combination of two lens system, that is this lens of glass and this is the lens of this liquid. And for this glass we already know that the focal length of this glass I have represented it with 1. So the F1 by F1 would be equal to 1 by R, and we have now 1 by F2 would be equal to mu2 minus 1 by R1 minus 1 by infinity. Since other side is infinity, so other side is plane for this liquid, so we can say that it would be 1 by infinity. Now R1 for this would be this side, which is equivalent in magnitude with this one, and its center would lie on the left hand side, so we can write it as minus of 1 by R, which was calculated in the previous part. So we can easily write as R1 as minus of R. Now substituting 1 by R1 as minus of 1 by R, we can get that 1 by F2 equal to mu2 minus 1 minus of 1 by R. Now we would get that 1 by f2 would be equal to 1 by r into 1 minus mu2. Now we will calculate the equivalent focal length. So we know that equivalent focal length is equals to the addition of inverse of the focal length, since they both are in contact and they both are thin lenses. So we can write as 1 by f equivalent would be equal to 1 by f1 plus 1 by f2. Now 1 by f equivalent would be equal to that of the glass and that of the liquid. So this is one that contains the liquid focal length. We have calculated it just now, and this is one for the glass focal length. So 1 by f equivalent would be equal to 1 by r times 2 minus mu2. Now this is the f equivalent for the case when the liquid is present between the lens and the plane mirror. Now again we will assume that there is no any plane mirror, because the plane mirror is only changing this direction of v. If there is plane mirror, then v is equals to minus of 45 centimeter. If there is no plane mirror, then v is equals to plus of 45 centimeter. Now we will apply the lens equation again with f equivalent. So using the values, 1 by v would be equal to 1 by 45 and u would be equal to minus of 45. So minus of 1 by u would be equal to plus of 1 by 45. And this we just found out. And substituting the values of r, we will solve this equation, and then we will get mu2 would be equal to 2 minus 2 by 3, and which will be equal to 1.33. That is, the value of mu2 would be equal to 1.33. Thank you.